Welcome to SVCH Talks, where innovation meets inspiration, and every conversation sparks transformation. Here we unlock the future, share cutting-edge insights, and empower you to lead the way in a world driven by knowledge and discovery. Let's elevate together, because the next breakthrough starts here.
We're thrilled to have you join us for a day filled with insightful discussions, groundbreaking innovation, and transformative learning. Today, you'll have the unique opportunity to hear from industry leaders as they share their expertise, experiences, and best practices. Before we move forward, remember that you can obtain the micro-credential for this event. Just follow the instructions on our website. Don't miss this chance to certify your participation and learning. Now we're ready to start. Let's dive into the broadcast that our team has prepared for you. Enjoy it.
Hello, hello, hello. Hi, everybody. Welcome to this new session of Conciencia Artificial, which is like actually a podcast. Sometimes we have webinars like today, and sometimes we have conversations, which is like more podcast type. But this time we have a good and interesting session about AI in factories, and we have Trista Li here with us. So I will introduce you, but first I want to say hi, Trista. How's everything going? How are you?
Hi, it's going well. Super excited to be part of this program. I'm excited to share what I have seen in the factories and in the farms with people who are curious about AI. And thank you for providing this opportunity. Super excited about it.
No, thanks to you to dedicating all this time to share all what is happening in the industries, in factories with AI. So good. So I will introduce just to give a little bit of idea of who's Trista Lee. So she is an AI go-to-market strategist specializing in legacy industries, thinking about automobile, TNL, and food agriculture, with a track record of drawing from zero to one on these industries, AI startups. She helped like venture break into the world's largest players, including Tesla, LG, GM, and securing multi-million dollar funding and turning this chaotic challenge into scalable solutions. So we have Trista Li here, and the the stage is yours. So if everybody have some questions, like feel free to write it here in the comments, and we will have time later. Also, I will prepare some questions for you, Trista, so we can have a later Q&A.
That sounds great. Super excited.
So I will share your presentation. Is your time, Trista?
Great. Awesome. Thank you, Alejandro. So I really wanted to thank everyone for this opportunity for me to share a bit about what I have seen in the last couple of years working in a startup environment. Like Alejandro mentioned, I have some experience deploying AI technology into the factories and also have understanding of the farm environment as well as agriculture environment. So I thought today it will be great to talk about what I have seen. Before I dive in, maybe I kind of wanted to talk about why I'm inspired to share what I've learned. One thing I'm seeing in the industry, specifically in the legacy industries like TNL, transportation logistics, automotive manufacturing, as well as agriculture, is they're not the most front-end digital industries. So when it comes to the concept that's new as AI, many people don't know where to start. And I hope that at the end of this conversation, we get an idea about what are some of the key foundational pillars of AI transformation where is the majority of the hype that's happening, what's actually happening in the factory floors or on the farms. And if you are a business or a leader thinking about adopting AI, what are some of the strategic way to think through the steps? Like Alejandro mentioned about my background, I have worked in the AI space since 2020. I joined a startup called UnitX that focus on AI machine vision in the automotive industry. We primarily automate the end of the line inspection. And from that, I learned a lot about how the digital transformation that's involving hardware in a legacy industry, legacy environment looks like. Then I have worked at Data Assembly, which is a data company that sells industry intel and industry data to larger retailers. That also exposed me to what it looks like in a retail environment, how important these data infrastructure really is. Ultimately, recently I've been working more hand in hand with many ag tech company to understand how to use AI to drive transformation. So I'd love to kind of talk about in general what I have seen in these relatively legacy oriented industries. So maybe we can take a step back and think about, when you think about AI in factories or farm, what are the things that came to your mind? I kind of highlighted some of the hot topics that we see on LinkedIn or on the news. For example, humanoid robots. We're painting a picture that in the future, many of the human tasks that's currently carried out by individuals are going to be automated. Lights out factories, completely fully automated factories that doesn't require any human intervention. You push a button, you don't need to have the lights, there's no individual on the floor, everything is automated. Full digital twins, so you have a complete digital record of whatever is going on in a physical world. You can manipulate things, you can control things with that. On the farm, we have swarm robotics, things that you can control what's going on in the farm using aerial imaging or aerial applications, AI-powered drones, or fully automated farm, right? Like imagine you have a farm that you don't have pickers, it's all robots or it's all computer visions. But when we think about the future that far out, how much of the reality really mimics these applications? Like what percentage of these applications are actually being deployed into the factory floors or farms? When we look at these cool tech, the actual adoptions are not really big, right? If you look at humanoid robot, it's less than 0.1%, or ranging for AI-powered drone, that's a bit more adopted. But more so when you take a deeper dive into what's happening in the industry from the industry news, you notice that many of these initiatives seems to have some challenges of being massively adopted or widely adopted. For example, the image you see here, it's about the underwater data center by Microsoft, and they stopped this project a few years back because it's difficult to become a standalone product. Or Google's moonshot project Mineral that focus on using machine learning and machine vision to make agriculture management much easier. They also become difficult to become a standalone project. The technology is very valuable, but the exit seems to be more of a being acquired or being part of a larger ag retail company. So why is that? Ultimately, when you think about deploying AI technology or thinking about the technology, the state is different from what we anticipated. So earlier, we're seeing, what are some of the key new applications that people had impression these are the, what does it represent AI in factories? But in reality, what's actually happening in the factory floors? For factories, mostly widely adopted and high growth applications, when you look at it, includes automated visual inspection. So at the end of the factory line, right now there are human looking at how the product is being packaged. Is it ready to be shipped? Are there any defects? How am I assembling things? These are very human intensive process that's still relatively error prone. So can we use AI, machine vision to provide a much more standardized judgment on the quality while it is still able to create these flexibility in the judgment process? That's one area that is widely adopted. I've seen firsthand. Predictive maintenance is another. So imagine you're on the factory floor and your machines are not being maintained. It's the same concept of I have to change my tire when the weather is bad, so my snow tire needs to be scheduled to be changed at this time. But other than the maintained schedule or any event-driven maintenance, is there other type of ways I can have a better monitor of the health of these equipments that I'm using, right? So that's where predictive maintenance is coming in. Industrial co-pilots for knowledge deployment. Like, for example, I have frontline individual doing work, but I might need additional assistance. Are there ways we can draw the information, not just by calling someone, but from a reservoir of information that's already there? Demand inventory forecasting. Now that not only we use the model, but we are having adaptive model to using machine learning to help us understand what are some of the future demand needs or for inventory needs. Those are the areas they are more widely adopted than the ones that we usually see in the factories, in the industries. The next will be thinking about the farms, right? On the farm, there's automated guidance and steering. So for farmers, a lot of the time, they have to drive their equipments for a long hour during the seeding season and harvesting season. This is where autonomous driving can kind of come in to support, not 100% replace, but it helps support some aspect of that labor intensive work, and it's really widely adopted. Yield mapping and harvest prediction are becoming more and more popular, primarily because you have more of the IoT insights, what's going on the farm, and then you can have aerial imaging or satellite imaging to collect the information that helps you make that insights. It's more popular among wider kind of bigger farms because it has a bigger land and bigger acreage to kind of help understand where that decision making needs to happen. Beyond that, we have precision weed control. So traditionally, we have the tractors, right, going into the field. But now with the tractor having the vision, they can collect information and understand how to make that decision in a smart way to, for example, spot spraying, to do weed control, or understanding how the field is. That is what AI can enable, and it's a very high growth area. Livestock health monitoring. So you can add the vision system into the livestock, or for example, you can monitor how your cattle is doing, and then using the image feed to kind of draw conclusion of whether you need to do certain intervention of the current way you're raising your cattle. Variable rate seeding and fertilizing, that is starting to be also a very big topic in the industries. So there is still a gap between what we think the hype of AI and the reality is. If you look back, for the factory to achieve fully automation, like lights out, humanoid, it would require a pretty heavy investment on the hardware. Many of the factories are currently in a hybrid mode. You do have autonomous vehicle moving around to do certain assistant tasks, but it still needs to work towards how the factory is built for human to be part of a big majority of the operations. So in order for industrial AI adoption to be fully realized in the way that we see, what are some of the key challenges? And I summarized in the following ways. Number one is the hardware barrier. So unlike digital AI transformation, for any physical-based AI transformation, data collection is very critical. But these data collections are not simply done by just writing software. It requires a hardware interface. The IoT sensors, the cameras, or even just some type of data collection process adds additional physical infrastructure requirement for these transformation process. And that is a part that's a bit difficult, a bit expensive. Moreover, with the hardware, there's also the hardware to hardware or hardware to software integration that adds additional barrier. Traditionally, in digital transformation, if it is happening in a software environment, the API or the other way to integrate with each other can be done in a relatively similar team, right? Like among the software engineer with the software engineering team. But when it comes to in a hardware environment, it would require your upstream process, for example, if it is in more of a mechanical design, to talk to a software interface, then talk to a additional process decision making. And that means you would need to interface with multiple teams, including automations engineer, the data engineering team, and also the software engineering team. So it adds complexity, hence some degrees of talent barrier. But also it adds the complexity of how things can happen in a streamlined way. Because in different factories, the upstreams are all different, the downstreams are all different, the teams are all different. So that adds complexity when it comes to hardware integrations. Moreover, for a kind of infrastructure like a factory or a farm, the original talents are not often AI ready, right? It's more likely to think about a production-oriented manufacturing facility is focused on production, mechanical, or the other hardware-oriented infrastructure. So when you need to introduce AI into this existing talent group, how do you introduce the AI ML talent into this group? Does that require hiring, or does that require upskilling the existing automation team into a certain talent? How would these new languages of AI interface with the rest of the company? How would the optimization of AI project interact with the rest of other stakeholders? KPI, for example, if I'm going to introduce AI into my production line and I'm a production manager, that means I have to face the uncertainty of how this new technology is going to impact my current production rate, my throughput, my KPIs. So how do you interact with this type of human transformation journey, right? Last is when you introduce a new technology that is AI driven, it's difficult to immediately justify the ROI given it's a new technology. There's a high infrastructure update requirement. And how do you think about the cost allocation for these projects? That's another big question. So to kind of further break down these three big buckets, we can think about 5 specific areas where, when we think about evaluating or adopting the AI adoption, how successful they will be. The first is time to data. As I have mentioned, IoT readiness, hardware readiness, that was a big barrier of how fast you can actually get to data. If you need to already deploy some of the hardware, then you get the data. that would lead to a longer time of getting the data. And then the next is internal AI capabilities. Do you already have the software team to be upskilled to speak the language of machine learning requirement, AI requirement? Or is this a much more complex environment where it's more hardware oriented? Or it could also be more operation oriented. So how do you kind of support the transition of language if you are going to deploy an AI application? That is also very important. The third part is the hardware and the computational infrastructure. As we know, for any AI-based technology or AI-based application, you do need a significant amount of computing power. And when it comes to deploying a product, there is certain requirement of data governance. So for example, if I am going to capture millions of images on your current production line, and in this process of capturing the images, where are we going to store the image? How are we going to process the image? How is the decision going to be done? Is this from the edge? Is this from the cloud? These are all going to be based off your computational infrastructure as well. And oftentimes it's not something readily available for factories that is not forward thinking about the AI yet. So that's another big barrier. Then we talked about the integration, which is how do you make sure the Python is able to talk to the rest of the hardware, or maybe there's other type of language. So how do you get hardware to talk to hardware through what kind of integration, how streamlined this is. And the last is the ROI clarity. So by introducing these 5 major points of evaluating AI applications, I prepared some additional applications for us to look at, just so we understand how we're thinking through this application. The first one is automated visual inspection. So automated visual inspection, as I mentioned earlier, it is the goal is to minimize the human error when it comes to shipping a product. It's pretty well adopted. It's pretty well adopted in the high-speed single unit automated production line. For example, for bottle canning, these are very well adopted even before the AI technology has been starting to introduce into the factories. So the traditional automated visual inspections are usually done using rule-based logic. For example, if you have the image capturing at this specific location, and we're always anticipating to see the tab of the can going this way, we're only looking for how the tab is done. And this is hard-coded by the pixel, by the location, and that is something that could be achieved long time ago. But the rule-based inspection has its limitation when it comes to highly variable product. For example, you have a certain judgment if this defect is a yes or no. That's not specifically measured. It's more of a, like, for example, if you have a nix and ding on a phone case, right? The QA manager will understand, oh, this depth, this length is a no, that is a yes. Some of these more judgment based on human intuition is difficult to be coded, hard coded into the traditional rule-based. So that's where the AI and the machine learning can come in and do a very good job. So starting from 2012 and onward, you're seeing a shift towards more AI machine learning based visual inspection system used to replace judgment-based quality inspection in the automotive industry, primarily to enhance the quality control rate. Because human inspector A and inspector B might have different judgment that it's difficult to articulate by rules. But if you're able to train the machine learning with the same set of data, same set of yes and no, they can learn and provide a rather streamlined judgments throughout the entire process. So that's where AI is pretty well adopted. However, you're not seeing that every factories in the world are using AI inspectors, and here are a few reasons. Number one is to train a high caliber quality based inspection system, you need a lot of examples. And a lot of example would be based off a existing library of all the previous defects, and sometimes it's difficult to get. So especially for new products or for smaller operations, these are difficult these are difficult images to get to train the machine learning to the point that's ready to be deployed, right? So that's where we see a dip for the time to data. The second is infrastructure. So if you want to support this high computational power in making decision at 3 seconds per part or 3 parts per second, you need a very high computational speed and also pretty high computational power. With current automated lines, many of them are still using PLC, and many of them are unable to kind of have this like intelligent component in the infrastructure. That's where it could be a bit challenging. You will see that both computational infrastructure and integration poses a big challenge for this technology to be widely adopted. Finally, it is the culture and ROI. So when you think about the entire production line, from production manager, from the automation manager to production manager to quality manager, eventually to the plant manager, by introducing a AI to do the inspection, there could be the conflict of production manager saying, if this AI is too good at picking everything that we in the past might have let go, that will hurt my yield. Versus the quality manager will say, yes, but this is able to pick every defects that I want it to pick. So it kind of intensify this potential conflict between the two groups. And how do you navigate this, right? Like if you have a conflict, it's possible one part might veto, usually production has a bit more power, and the production might veto the introduction of a new technology, especially it's unsupported by an ROI calculation. So those are very important aspects to think through when you are introducing visual inspection element into the modern factory. I hope this is a good first example. We're going to move to the second one, which is predictive maintenance. So if you think about predictive maintenance that happens in a factory, it can be high, like for example, you have this stamping machine that is going through to stamp your product and then able to see if it's meeting its production rate. It has scheduled maintenance every 3 months, and it has reactive maintenance if something broke. This would oftentimes lead to unnecessary downtime or wasted parts because it's possible when we're doing calendar-based maintenance, it might be beyond its prime, or if you're doing reactive maintenance, it might be doing a trade-off with our production schedule. So if there is condition-based monitoring, for example, if I'm able to gather the data from how the thermal is, how the tool is, then we will be able to have a way to either early alert or defer the preventive maintenance that's calendar-based based on the existing process or existing state of the tools. So that's something we see adopted by the factory, but still not fully widely adopted. The key reasons include, first is data silo. So operational technology data is often locked in legacy PLCs, like I said earlier. And how can we get PLC data to interface with the rest of the entire department, especially, PLC is controlled by the automation and the engineering group, whereas the IT and the maintenance is in the operation group. Those two groups might not always be in the same group. So how can we get PLC information to integrate with the IT analytics platform? That is a challenge that can cause the time to data significantly lower, right? So by the time I get the data, it might already be late, or I don't have enough of a cameras, or I don't have the sensors to actually capture these field level data. That's a challenge. The second part is the cold start problem. So this is a little bit about the process. If you start with the machine that's reliable, and you don't have sufficient failure data to train the models on, then how would you know when this machine needs to be maintained? If this is a one-off machine that's custom built for you, then there is no historical information, and that is challenging to justify for a new kind of sort of like a predictive maintenance program. The last is context awareness. So algorithm might not be able to differentiate what is a legitimate issue or a operating change. So for example, if I am going to make a decision that is more on the fly, this week we're going to pause production primarily because of that reason, your AI, if not informed on the context, it's a bit difficult to immediately change. So that means there's additional operational barrier for the entire team to kind of navigate around. That's an additional cost and friction point for any team to veto, right? It seems like it's kind of costly, expensive to do. Some of the more difficult applications within this will be maintaining the CNC machine or maintaining the slow rotating equipments. And those are primarily because you don't have enough data, a constant changing environment that makes it not as adaptable. So that could be a big area of challenge. In comparison to the visual inspection, predictive maintenance is focusing on the equipment that is providing the service. Hence, the cycle time of getting data will be in a much longer period compared to let's say you have millions of parts going through the conveyor belt. Like that is something you constantly have data. So the first challenge to jumpstart is the cold start problem. And beyond that, you can see that the internal buy-in that you can get from infrastructure and integration seems to also be a bit difficult to maneuver as well. So it is, in comparison, a bit lower in adoption rate. But I'm really optimistic that this can be the future that we're moving towards. The next example will be autonomous mobile robots. So what that means is these are the robots that's operating on the factory floor to kind of help load stuff or kind of help move stuff around. Traditionally, automated guided vehicles follow physical lines, right? Imagine you're at like Cleveland Clinic. There are underground magnetic lines for certain conveyors to go in order to fetch the equipment or the medical equipment or medicines to be shipped to the front of the house. So that's a traditional approach. But now, by adding intelligence layer, the cars can be even more autonomous in navigating the process that doesn't have the pre-planned route for these vehicles. You do see some of the adoption of these in a slightly more freely adopted route. For example, how do we navigate in a warehouse situation, just doing loading and unloading? There's AMRs being adopted for using as a pallet. So autonomous pallets unloading products and then coming back to the truck, right? Those are examples. These are starting to be well adopted. It doesn't have as much of a challenge of time to data, primarily because the product itself collects data in real time. So you don't have that big of a challenge. But the challenge in adoption usually is in the feasibility, because the factories today are very chaotic, and it still poses the challenge of like, how would a autonomous vehicle going into the factories? The fleet also has specific requirements on standard communication, and it can make it very difficult going from one vendor to the other. Battery management is another big challenge. But ultimately, I think the ROI clarity is difficult for factories if they are not in high volume, high production. If we take a step back and think about transportation and logistics, many of the larger warehouses are already doing, they're adopting AMRs in areas that requires a bit more autonomy. But when they are just automating this component, sometimes they would want more of that component as well. For example, I already have a cart going there, might as well have the gripper, but the gripping ability is not there. So when you put together and think about the ROI clarity, it's possible the ROI clarity is subpar of what they're thinking about for mid to smaller operation that's interested in a upgrade like this. Some of the high difficulty applications include outdoor-indoor transitions, primarily because rain, glare, lighting, those are very difficult for the car to kind of maneuver through. And then the precision docking, aligning heavy payloads, these can also be very difficult. Now we're gonna take another route into the transportation and logistics area to think about logistics sorting. So I'm a bit more familiar with this example because I've seen some of the applications in the ground. So imagine you're in these like large warehouse like FedEx, UPS. They have crazy amount of parts coming through. You need to ship them. You need to kind of sort them into different trucks, or you need to sort them into different buckets. Traditionally, the 1D barcode scanning is already implemented for a long time, but there are limitations by some of the rigidity of the package requirement. In the past, you have the scanning, you also have the human in the line, but in the process of having fully automated line, there are the challenges of how the physical package, the size, and all the size of the size, the color, the edge case of these packages that can cause the process not being fully smoothly carried out. So, for example, the current state right now is AI vision with robotic signalation, including system that can identify, pick, and sort unstructured mixed SKU item using 3D vision or 2D vision just itself. But the adoption here can still be challenging, with part limiting by the vision, part limiting by the gripper. If we think about how this go into the 5-star equipment evaluation framework, the time to data can be done pretty quickly and the computation is pretty fast, but you don't necessarily have the internal AI and ML team, right? Usually the skill set within a logistics factory is not exactly there. The challenge is the integration. You're essentially asking for infrastructure transformation, going from having human as part of the process to being fully automated. So how do you support the robot? How do you support the camera? How do you support the evenness of the lighting? Those are all big challenge on the integration. The infrastructure for computation. So you're going through loads of data. How do you think about the computation infrastructure? Are you going to do this on the cloud? Are you going to do this on the prem? Those are key questions. The ROI clarity is quite high in this use case, primarily because if you misshipped 1% of your product, you can quickly estimate the operational cost to recuperate and then the cost to the end customer. So if you can have certain percentage of improvement of sorting precision, then the ROI case can be quickly calculated. So the calculation is there, is not something completely new. We talked about some of the challenges, but another few things to consider includes like gripping physics. For parts, how do you grip certain heavy parts or not geometrically uniform parts can be a challenge. Edge cases like the packaging are wet, they're crimpled, barcode is missing, new packages that you have never seen before. These are a challenge. And throughput speed, that could also be a challenge for robots to kind of pick through with the time that you need. One thing about, without going too much into depth, oftentimes throughput is connected with computational infrastructure of how fast you can calculate, and there's oftentimes trade-off of how fast you can do and how accurate you can do certain things. Cool. The last use case I just wanted to kind of glance through and talk about is the yield mapping for large farms. So for farmers, especially really large farms, in the past, they can run kind of traditional models to anticipate what is the yield for their what is the yield for their entire field. Sometimes they just do end of the line testing to understand like what is the ultimate state. But right now you can actually do the current state and the process parameter to understand if you need a correlation, and you need you have correlation linking the real inputs with the real outputs. So this isn't something that there's still a great amount of area to be improved. So take a step back, because I talked about different kind of applications. When we think about AI adoption in the factories, many of us are thinking about a autonomous future where cameras, where fully automated systems are able to run in our physical world. However, in order for a legacy operation to go from today to fully autonomous, there are multiple states to take. Right now, we're going from the analog to the more IoT connected way. So many of the challenge still comes into justifying additional equipment that can start capturing the data. Well, for certain companies that already have captured data, getting data structured from various sources and then making it into readable input is still a big challenge. So if you go back to look at the 5 different prompts, the time to data essentially is the level 1 to level 2, level 0 to level 2, where many of the company are navigating through. This is where the investment into infrastructure needs to be justified in an ROI, and some additional thoughts needs to go into how to streamline and standardize the way we manage and govern the data structure. From there, then we have the predictive learning. So essentially, we're asking to take a pretty big jump from level 1 to level 3, and that is where many of the transformation journey these physical companies are on. What are some of the existing challenges that's out there for companies thinking through automating their process or adopting AI in the mix of their automation? One of the more common challenge is for smaller productions, we have high mix, low volume problem. So if you have 500 variants of a part per month, AI is still unable to quickly adopt across all of these parts. However, we're seeing more and more of these one-shot learning that might be able to help. And these one-shot learning might be able to use to accommodate specifically process that doesn't require super high speed. The second is small and medium enterprise gap, where many of the family-owned stores are thinking about going from a current process to directly including the AI. So do they actually invest in a hardware that can do everything, including the data science team would do, or do they invest in a data science team? So we are starting to see more and more the no-code interface and plug and place hardware to kind of come in and solve this problem. The key question is, while this is a solve, how much do we anticipate the current customer actually understand the data science fundamental to actually say your calculation is incorrect, right? There is a bit of a trade-off between being done in a simple way and being done in a high precision way that remains to be uncertain. The last one is no infra frontier for agriculture. For example, a soybean farmer in Brazil or a mine in Nevada, they don't have 5G or infrastructure to actually support the calculation. So how do we think about using, for example, cloud computing or some other ways? The extreme edge computing is something we're seeing. For example, we're seeing some of the autonomous parts, for example, at Boston Dynamic, they're doing the the cars that, for example, the cars can go in no Wi-Fi, no signal environment, very extremely dangerous environment, very remote environment. That might be a potential solution, but the ROI for soybean farmer versus the extremely high cost for extreme edge computing, how can we see these two going into the middle? That remains to be seen, how technology iteration can get us there to meet the ROI requirement. So those are some of the things for us to think about. Hence, this kind of conclude to my very elementary introduction of the conversation around how we think about AI in its actual form in factories, talked about some of the applications, and yeah, welcome some questions or discussion.
Amazing, Trista. Wow, super complete. I love it. You really dedicated like really good analysis, which is what we needed. Because
Thank
sometimes
you.
is we had in the past conversations about AI, but are like, oh, those things is important. Like we have to think about A, B, and C. But to give examples, to disaggregate the problems by steps is really relevant for the audience and for what we need in general to understand and to know more, if we want to apply AI in our operations, different businesses, different industries. So I love it. Really great
Thank you.
presentation, Trista.
Thank you. I'm really glad. Yeah, I was very surprised that when you think about AI into kind of legacy industries, it's a very different thought exercise than introducing this into a completely software environment. If you're integrating your CRM software with your email, that is just one click away of some API exchanging information. I'm not an expert in this, but I assume that's what happens. To say the least, the process is fast. However, for a hardware company to integrate hardware in the industrial automation world, there's a thing called integrator. So you do hire a third party to actually help you carry through, and it's a very customized, very consultative process that takes time. So imagine introducing AI in an industrial environment. Every project might require this amount of consultative process to carry the integration. That's actually a much longer cycle. So that's kind of what led me to explore what are some of the key layers. It's very elementary of a analysis, but I just hope the audience get a flavor of what it looks like. That might not be as simple of a journey because there's multiple layers of things for specific AI adoption to happen.
Agree. Okay,
Yeah.
nice. Good. So we don't have a lot of data. There's a lot of things to analyze from software to hardware and so on. But so far, how do you recommend to measure the impact or the investment to move from analog to predictive? Like at
Mm,
the end, there are like 4 steps, and it's a lot going on. So, how
yeah.
do you recommend, or what do you see as best practices to talk with the CFO and tell him, like, hey, we need to invest on this because this will be the impact and that will be the result in the bottom line?
Yeah, I think that's a great question. So when you ask me this question, the first thing that comes to my mind is think about the successful projects that I have seen. Oftentimes, when people are thinking about introducing AI, they're anticipating a replacement, right? They're anticipating a one-to-one or one-to-X replacement. I'm automating my process with a like human intelligence. I'm going to replace X amount of headcounts. But when you're doing these headcount replacement exercises, it's difficult to justify a ROI that might be recurring every year. So what I find most helpful in terms of kind of a high kind of a high return on investment project is when you look through a company where they have capacity bottleneck because of the current human process, and then they have exponential production needs in the next year to come. For example, I have 4x demand where human just cannot simply do this task. You're thinking through a process where you need exponential kind of production growth. That's where introducing AI can be a very good justification because you have the production gain, you have the efficiency gain, and then as a new project, the infrastructure requirement can potentially be justified in your capex expense. And those are the project I've seen being most helpful. Um, Otherwise, it would be more associated with something they have not done before. Like I've never solved this problem. I really want a one solution, one button click to kind of solve this problem. So it's painful, and everyone has recognized the pain. So earlier we mentioned there's always this balance between production and quality, or some department with the other department. If you have an internal alignment of all departments knows this is a pain, everyone has some pain, and by eliminating this pain, everybody will be happy. That could also be a really good area. It might not be as ROI driven, but it's easier path for getting that consensus across within an organization. I think those are usually the production part. Is let's say you have a new contract, right? Like it's more on the revenue enablement type of ROI discussion can make AI applications a lot more favorable. If it is more on the operation efficiency gain perspective, it's usually difficult. I find that eventually for an automotive company or manufacturing company, if you're able to justify their over equipment efficiency plus some production gain or productivity gain, that could make the ROI discussion productive and also informative.
Amazing. Yeah, totally makes sense. And sometimes it's like difficult to move to not think just about ROI, more about
Mhm.
like what's the actual problem that is solving, and and move from there. So and I think I will have time for another question. If somebody have questions, please write it down. But so far, what I have in mind is you mentioned about the black box issues, like the models are black box. And so
Mhm.
far in the market, there's not enough talent to be able to solve like this gap between the actual needs, the problem to solve, and the black box models. So, what is your recommendation for executives at the end? Like
Mm.
how like trust in the models, find like some super expensive talent out there that can help, or like for executives, what will be the best way to 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 solve this issue?
I think what the market needs more is to understand what are some of the standards the current production or operations are holding. So, if I'm adopting a perspective of a very talented CEO who wants to create a technology that simplifies these AI models deployment into factories that's just small, medium size, they still don't understand what is the critical threshold that we need to meet for our product production to get there. So an example will be if I'm producing mouse, like these mouse, I my end customer would only allow, let's say, 1 part per million parts I create to be a defective part in order to meet a satisfaction requirement. Right now, how can we create a test with our black box algorithm to support the CEO meet that one defective part per million parts produced? That journey is not as collaborative as I have seen. Right, many CEO wants to say, "Hey, I just want to buy this black box of your software and then put it on the line. Eventually, it just helps me get to 1 part per million result." Is that possible? But for a new product, you still require that understanding of how to work with the CEO. My thought is for medium, small businesses, if you're thinking about adopting AI, it might be worth it to find partnership who are thinking about the solution than hiring a complete team in-house to create a new solution. Chances are there are aspiring CEOs or startup founder trying to solve the problem, and your industrial contacts and input might actually help accelerate their productization of the solution while with your requirement at the end. um, that might be cool, right? Like you partner up with a startup to kind of understand how the process goes. um, Leveling up on their understanding of AI is also helpful. Like conversation like today gives them a bit more of a what's under the hood of this black box beyond the super technical part. What are some of the other things that I should think about if I'm introducing AI into my operations? I do think that could be very valuable, kind of a mapping for what does that mean next couple of years if I want to introduce something. What are even the non-technical part I have to adjust to adapt for that? So I hope that's helpful. Yeah.
Yeah, totally. Good. Actually, we are running out of time. Hopefully, it doesn't disconnect. But I just want to thank you so much for your time, Trista, for sharing those amazing examples, like how you break down like everything, what is happening in factories, in industries, in farms. So really impressive, really nice what you are doing. And let me share with you again, with all the audience again, your contact. So if you have any question, like, feel free to send her an email. Um, that's it. Anything else, Trista? Uh,
No,
s-
it's thank you again for this wonderful opportunities. I just hope that by sharing my learnings, I might be able to help people get a bit more insight into what's going on actually on the floor of AI's transformation in these legacy industries.
Amazing. Well, thank you, Tristan, and thank you everybody for this great webinar, for attending. Also, will be online in our LinkedIn and YouTube platforms. And you have the Trista contact. So thank you, everybody. Have a great rest of the week.
Thank you.
Bye.
Bye.